Should we build microservices from day one? Well, that depends. What's breaking? Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today what I have for you is a reaction to a post on LinkedIn by Muhammad Umar. And I found this post very interesting because it's talking about when to switch to microservices, if ever. And let's see what he has to say, because I believe this is a very interesting post. Monolith versus microservices at 1 million users. CTO asks, should we build microservices from day one? We are hitting 1 million users. My response surprised him. What's actually breaking? That's a very interesting perspective, and I haven't seen this one until now. Normally, the way I make this decision is by first identifying what are the necessary non-functional requirements, and then based on that figure out which are the parts of the system that actually need to scale. And you can do that with prototypes. But this is when you start from scratch. And now, if you want to switch to microservices from an existing application, it's even better, because in that case, you actually have more data. And so this question becomes very relevant. Okay, so my response surprised him. What's actually breaking? Turns out it wasn't the database, wasn't the servers. It was their 15 minutes test suite running 10 times per day across the team. 3+ hours of collective waiting every single day. Okay, so let's stop and think about this for a moment. It's very important when you want to use automated testing, and you should want to use automated testing for most applications, to figure out what is your testing strategy. Having 3 hours of collective waiting every single day, well, 15 minutes test suite, 15 minutes test suite, running 10 times per day across the team. Okay, maybe it can be faster. So if you have 15 minutes test suite, I know teams have hours and days of test suites. Even with 15 minutes, you can probably look at improvements and optimizations. And there are optimizations that don't require you to change the way you wrote the tests, that can be running in parallel, running the tests in parallel, buying some more servers so that you can run more things in parallel and speed things up. But most of the times, that's not the problem. Usually the problem is that you are using too many high-level tests and too few unit tests. So let's think about it this way. You have fast tests and you have slow tests. Fast tests are the ones that run in memory. Slow tests are the ones that require access to external resources. File systems, databases, networks, external services, etc. You want to move as much as possible of the testing inside the fast tests. And please note that I'm trying to avoid now using unit tests, integration, and so on. There are some rules there that you can follow, but typically these terms have become so polluted that it's not clear anymore what we mean by those. But just think about it this way. If you have tests running in memory, depending on the programming language, Java is a bit slower, for example, you can run 1,000 tests, maybe more, in a second. Okay, or maybe 300 tests in in a second. It's still okay. So you can scale up this infrastructure very quickly. And then if you add in some additional servers and so on, you can run a very large test suite in memory. And so if you want to run all the tests on every commit, then that's a problem, or on every merge or on every pull request. Maybe delay some of the slow tests for the end of the day. That might be an option. But generally speaking, have a lot of fast tests, just a few slow tests, and go with it. And I know people keep complaining in that case when I tell them, yeah, but only end-to-end tests tell us if the system is really working, blah, blah, blah. Yeah, that's not true, actually. You can do it in a logical way. If you have an end-to-end flow, if you test every piece separately, and then you make sure that they combine correctly, you have tested the full end-to-end flow with separate fast tests. So there is a way of doing that, but it requires a little bit more care, a little bit more knowledge, a better testing strategy for structuring your tests. But let's go back, because that's not the point. I just really wanted to talk about tests here, because to me, this is probably something that you can improve. The point is what comes next. Everyone thinks they need microservices to scale. 90% of time, microservices is an organizational solution, not a technical one. Amazon needed them for 100,000 plus employees who couldn't coordinate. Netflix needed them for 500 plus engineers deploying simultaneously. Your 8-person startup, you don't have those problems. Very interesting. And that is actually correct. One of the case studies or the initial case studies for microservices architecture came from the idea that they had to start a project and scale up the number of people very quickly. So they needed to compress the timeline, and they figured out that the way to compress the timeline was if they could add a lot of people very quickly to the project. And so how do you do that? Well, Conway's law. If those people don't need to talk between each other, let's imagine you have pairs of developers that work on their own thing, and they don't need to speak between themselves, because a lot of cost is coordination cost. Then what you have is something that you can scale up very quickly. How do you do that? Well, you need to make sure that the architectural entities you deploy match the communication patterns. So if the pairs of developers you don't want them to speak to each other because you want to avoid the coordination cost, what can you do? Well, you can deploy separate services that are small and that only talk through events, because in that way they are completely decoupled and they don't know about each other. They only know about the message queue. And that's how you get microservices, deriving from Conway's law and from very specific constraints. So indeed, this is one way you can scale up. So he's correct here, because Amazon needed them for 100,000 plus employees who wouldn't coordinate, or who couldn't coordinate because they are too many. Netflix needed them for 500 plus engineers deploying simultaneously. Again, independent deployability. That's the key with microservices. That's where it helps. So if you have a lot of people who can work on their own things and just update some stuff from time to time, then microservices are perfect. I would say there are also often some non-functional requirements, concerns here. Although probably you can deal with those most cases with larger services. It doesn't have to be microservices. You might also be able to deal with those in other ways, through the database, through batch processes. There are various ways in which you can scale things up depending on the problem. What actually breaks at 1 million users? I have seen the same patterns over and over. Connection pool exhaustion around 800,000 users. Most teams use default 100 connections. Yeah, so database optimization. Network calls that turn 800 milliseconds request into 3.3 second timers. I think you wanted to say 2 to 3 second timers. Memory overhead that is 24 gigabytes before processing a single user request. None of these require microservices to fix. That's true. You can fix most of these through infrastructure. So connection pool exhaustion, figure out what the database server, how many connections can you use. Network calls, that's probably a network problem, although these are difficult to find a general solution to, because they are systemic, so they may have different sources. Memory overhead that is 24 gigabytes before processing a single user request. Yeah, I think this is more likely to happen with garbage collected systems, because in that case, typically programmers don't pay as much attention to memory, and they also kind of consume a lot when they start. So it depends on your technology, but probably if you switch to Rust with some good developers, you can deal with that and make this faster. None of these require microservices to fix. The companies that actually scaled, and I like these examples, these are great. DHH, so DHH is David Heinemeier Hansson, also known as DHH. He was he is contributor to Ruby on Rails, and he is one of the co-owners, I think, of Basecamp. So DHH built Basecamp to millions of users, Rails monolith still running. That is true, but I happen to know a little bit more about, we happen to use Basecamp, and they are very interesting as an organization. They have spent a lot of focus on performance. The response times in Basecamp are impressive. It's almost instantaneous. Almost anything you do is just immediate. And yeah, you have a Rails monolith serving this, but there are a lot of details to pay attention to. They have optimized the HTTP requests. They have optimized their APIs and so on. There's a lot of work there, caching and so on. So you can do that, absolutely. But, and okay, so DHH built Basecamp to millions of users, the Rails monolith still running. The thing is, they release a new version every probably 2 years or so. And that new version, I'm not sure it's a complete rewrite, but it's pretty much rethought, because the UI changes and it actually improves, and the performance improves as well. So I would say that this is correct up to a point It's not an application that has incrementally grown. It's an application that has been re-architected several times. At least that's what I think. Stack Overflow served 200 plus million monthly users with a monolith for years. Yeah. Again, because I read the blog posts of the guy who built Stack Overflow, whose name escapes me right now. He was very focused on caching, optimization, performance. So you actually have to pay a lot of attention to this in order to get to 200 plus million users. WhatsApp scaled to 900 million users with 32 engineers monolith. I have no idea what the technology behind WhatsApp is. This is impressive. Not necessarily the number of engineers. I think the number of engineers sounds perfectly fine. I think smaller teams tend to get better results than we expect, particularly when they know very well what they are doing. But 900 million users, still very impressive. I don't know what the technology is. I'm quite curious now. I'll have to look. Meanwhile, I watched 5-person team spend 3 weeks adding a simple feature because they build microservices from day one. Yeah. So if it's a small team, generally speaking, doesn't help. What we do instead. So remember that architecture is about socio-technical systems. So if you pick microservices architecture, but your socio-technical system doesn't fit this because there are too few developers, yeah, why? What we do instead, start with a well-architected monolith, yes. When you actually hit organizational scaling problems, usually around 50 plus engineers, then extract services strategically, yeah. Martin Fowler, who literally wrote the book on microservices, said it best. I have to correct him. Martin Fowler didn't write a book of microservices. He helped formulate an article that is very important on microservices, but the actual books were written by other people. Don't even consider microservices unless you have a system that's too complex to manage as a monolith. Yeah. Martin Fowler is usually right. So even though this is not, he didn't necessarily wrote the book on microservices, this is absolutely correct. Cost of fancy tech, optimized monolith at 1 million users, 50 milliseconds average response time, about 3K monthly infrastructure. Yeah. Typical microservices setup, 200 millisecond average response time, so 4 times worse. 12K, so 4 times worth monthly infrastructure. So now I'm going to believe him on these numbers, but this shows that what's the difference between 50 and 200. My guess is that a lot of it will be network latency. One of the big challenges with microservices is that they need to call either each other or to go through a messaging system. And because of that, you have multiple calls on the network, which leads to latency, which basically means that you are paying for your system to wait for things for quite some time. So 4 times difference, maybe not everything, but maybe another, the difference from 1x to 2x is probably latency, which can be really bad. The biggest competitive advantage is 2025, shipping features faster than your competition, not having the coolest architecture. Absolutely. And now I wanted to read another a few more comments because I think they were very interesting. Mike Desjardins says, I'd even say that microservices aren't best for addressing organizational concern. They are for deployment and infrastructure concern. Modern programming languages came up with ways to isolate and modularize code decades ago. You can build a monolith where teams can stay out of each other's way. I've seen lots of teams adopt microservices as an attempt to reduce team dependencies, and microservices aren't the only way to do that. I would argue here that even though we have modules in programming languages, they are not as good as they should be. We need modules with hard boundaries. And microservices have harder boundaries than the others. And I think there was another interesting... Okay, I cannot find that anymore. Comments. Agree, too many teams waste time solving problems they don't have. A clean monolith can take you surprisingly far if you just focus on real bottlenecks. And that's a very interesting point. You can figure out bottlenecks as you move and be prepared to modify your architecture in order to move around those bottlenecks. All right. Okay, that's about it, I think. This is another comment that I wanted to read. Yaron Levy. Also, no Kubernetes or any of that low-level nonsense. Use a platform as a service like Render. Use a cloud database like MongoDB Atlas. Keep it a nice, simple monolith. Let's talk when you've outgrown those. Yeah. And by the way, there are a bunch of different architectures that you can pick from other than microservices that maybe fit your problem better. And we have a full playlist of architectural styles. Plus, if you are interested in seeing me making architectural decisions on problems that I haven't seen before, you can join one of our performed architectural katas. We have more scheduled in the autumn, and until then there is one live recording from YouTube that you can watch and see if you learn anything, and if you'd like to join one of our future events. What do you think about all this? Do you use microservices? What challenges do you have? What other questions or comments you might have? Let us know in the comments. This is really great to have a conversation with you. Also, like, share, subscribe. It helps the channel. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.